We reach out, our fingers brushing against a loved one's hand, the rough bark of a tree, or the smooth surface of a polished stone. We feel the pressure, the texture, the warmth or coolness. These sensations are so vivid, so real, we believe we are touching. We trust our senses implicitly. But what if I told you that everything you think you know about touch is an illusion? That the very act of touching is a deception? What if I told you that you never actually touch anything at all? It seems impossible, doesn't it? Our entire lives are built around the sensation of touch. From the moment we are born, we rely on it. We navigate the world through it, using it to understand our surroundings. We connect with others through it, forming bonds and relationships. How can something so fundamental, so intrinsic to our existence, be an illusion? It challenges everything we know. The answer lies in the strange world of quantum mechanics, a field that defies our everyday experiences. To understand why we never truly touch, we must journey into this microscopic world, a universe so small yet so vast in its complexity. Imagine for a moment shrinking down to the size of an atom. You find yourself in a vast emptiness, a miniature cosmos populated by tiny whirling particles. At the center of this universe lies the nucleus, a dense cluster of protons and neutrons. Orbiting this nucleus are electrons, flitting about like hyperactive flies around a sleeping dog. These electrons are not solid objects like tiny marbles, but rather more like fuzzy clouds of energy, constantly in motion. They are the gatekeepers of the atom, forming a kind of invisible shield around the nucleus. Now, imagine two atoms approaching each other. It's like bringing two miniature solar systems together. What happens? Do the nuclei crash into each other? Do the electrons collide? No, instead something remarkable occurs. As the two atoms draw closer, their outermost electron clouds begin to interact. This interaction is a fundamental aspect of atomic behavior, and plays a crucial role in the way matter behaves. Electrons, you see, carry a negative charge. This negative charge is a key characteristic of electrons and is essential to understanding their interactions. And like charges, as any child who's played with magnets knows, repel each other. This principle of like charges repelling is a fundamental concept in both magnetism and atomic interactions. The closer the atoms get, the stronger this repulsive force becomes, like trying to push two powerful magnets together with the same poles facing. This increasing repulsion is due to the intensifying interaction between their electron clouds. This force is known as electromagnetic repulsion, and it is one of the fundamental forces of nature. It governs not only atomic interactions but also many macroscopic phenomena we observe daily. It is this force, this invisible barrier created by the repulsion of electrons that prevents the atoms from ever truly touching. This barrier is what gives matter its solidity and prevents us from passing through objects. When you press your finger against a table, the atoms in your finger never actually come into contact with the atoms of the table. This is a direct result of the electromagnetic repulsion between the electron clouds of the atoms in your finger and those in the table. They are held apart by an infinitesimal distance, a gulf at the atomic scale, by the relentless repulsion of their electron clouds. This tiny separation is what defines the boundary between different objects and gives us the sensation of touch. But if we never actually touch anything, why do we feel pressure, texture, and temperature? Why do we perceive touch so vividly? The answer lies in the way our brains interpret the signals sent by our nervous system. When you press your finger against an object, the electron repulsion between your finger's atoms and the object's atoms creates a force. This force is then translated by specialized sensory receptors in your skin into electrical signals. These signals travel at lightning speed along your nerves to your brain, where they are interpreted as the sensation of touch. Your brain interprets the strength of the repulsive force as pressure, the variations in the force as texture, and the transfer of energy between the atoms as temperature. Imagine for a moment, a world without this fundamental force of repulsion. What would happen if electrons didn't push each other away? The universe as we know it would cease to exist. Atoms would collapse into each other, their nuclei merging in a chaotic dance. Matter would lose its structure, its integrity, stars would implode, planets would disintegrate, and you and I would simply cease to be. Without the force of electromagnetic repulsion, there would be no solid objects, no distinct boundaries between things. The universe would be a formless, homogeneous soup of subatomic particles. The fact that we never truly touch, that our perception of touch is an illusion created by the interplay of forces at the atomic level, might seem like a bizarre and unsettling notion. But it is this very weirdness, this seemingly counterintuitive aspect of reality that makes our universe possible. The forces that govern the interactions of atoms and subatomic particles are the architects of our reality. They are the scaffolding upon which the universe is built, the invisible hand that shapes the world around us. Electromagnetic repulsion, the force that prevents us from ever truly touching, is not just some obscure scientific concept. It is the silent guardian that holds our world together, the invisible force that allows us to exist. So, the next time you reach out to touch something, whether it's the soft petals of a flower or the rough bark of a tree, to feel the warmth of the sun on your skin as it gently caresses you with its golden rays, or the coolness of water on your fingertips as it ripples and dances around your touch, remember this: you are not actually touching anything. What you feel is the interaction of forces at a microscopic level. You are experiencing the universe at its most fundamental level, where particles and forces engage in a delicate dance, the dance of forces that makes our reality possible. It's a symphony of interactions that we often take for granted. Take a moment to appreciate the weirdness of it all, the strangeness that underlies our everyday experiences. The universe is not always as it seems. It holds mysteries and wonders beyond our wildest dreams. The solid objects we interact with every day are mostly empty space, a vast expanse held together by invisible forces held together by invisible forces. These forces create the illusion of solidity and form. Our perception of reality is just that, a perception, a mental construct shaped by our senses and brain, an interpretation of the signals our brains receive from the world around us. It's a virtual reality created by our minds. And sometimes the truth is stranger and more wonderful than anything we could imagine. It challenges our understanding and expands our horizons than anything we could imagine. Embrace the mystery and marvel at the beauty of the universe.